And thanks for the invitation. When Dan approached me about what sort of presentation we might be able to give to customers that would be most useful, really what I've seen in my role as level 3 support over the course of the last several years is more and more customers moving away from hosting their user repositories on-premise in LDAPs and moving to modern cloud identity providers. So I wanted to talk a bit about web application security and how user repositories fit into that, their function in a digital experience-based application, and the differences that you will see if you decide to take this route. So with that, let's get started. Every presentation I give, I always like to set the context of what we're dealing with here in web application security. Not everybody is familiar with all the terms or the way that I approach the subject. So I'd like to start by just defining our terms here. So first of all, what is web application security? Simply speaking, it is information security applied in the context of a web application. And then, of course, integrated into a comprehensive security plan that you have for your organization. And that's important for maintaining users' trust in your application. So, of course, that leads to the next question: what is information security? So there are 6 pillars that can be divided into 2 different categories, right? And the categories correspond to what the application connects. It connects people to data. So what we're talking about today with cloud identity providers, of course, is the people side of the equation. And then within that category, there are 2 different pillars. The first being authentication and the next being authorization. So what do we mean by authentication? It establishes the identity of the person accessing the system. So it answers the question, who is this? Then the second step of that, of course, once you know who they are, you want to know what they can do. So authorization is the practice of restricting access to the data that the system controls, determining what data users can access and what operations they can perform on that data. So taking the first part of that equation, authentication, is the primary security requirement for most applications, just knowing who is accessing the system. And authentication is the process of verifying the user's identity. So when we drill down into digital experience, there are a lot of different factors to consider. The first being the user repository. Where do we keep record of who these users are? Integration with other systems via trust association interceptors. And that is Web's for Application Server term, meaning we're going to use a certain interface for determining user identity. If you're not dealing with things like external security managers, what we're talking about today are cloud identity providers, or you'll see other terms to address these later in the presentation. Digital experience is very flexible when it comes to user repositories. You can have actual user repositories like an LDAP, a database, or a custom repository, or even like in a demo system, a file repository. And you can also have transient users where no real physical user repository exists. It only exists in memory of the application. And that's very important when we start talking about how we approach cloud identity providers. And then there are many extension points on top of for digital experience applications, including custom login modules, custom login portlets, any number of authentication filters. As I said, you can, the trust association interceptor is simply an interface, and there are other ways to extend on digital experience functionality in the realm of authentication as well. But in the end, it is a very important aspect of security, and we do see it show up in the OWASP top 10 list under the heading authentication failures. And they break those out into several types. So moving on to the second aspect, let's talk a bit about authorization. Again, this is what can users do? We generally try to apply the principle of least privilege. You don't want to give users any more power than they have over your data. And you do that via various numbers of application controls. Usually you try to simplify your administration by defining groups to manage these users. And again, this is a very important aspect of security, and broken access control does show up in the OWASP top 10 as well. Digital experience provides very granular access controls over the resources it administers. We're talking about pages, portlets, all of the types within digital experience structure. You can apply some access control to web content, etc. So you can assign roles to those resources to individual users or to groups of users. And so once we get into the discussion about OIDC and transient users, that's going to become very important. And for the most part, in 99% of the applications I've seen, authorization for digital experience is self-contained. In other words, we manage that entirely within digital experience, the product itself. So it's a very granular, dynamic, and complex system that you can apply in a very powerful way. What sorts of ideas should we consider as we're thinking about digital experience and authorization? I mentioned earlier the principles of least privilege. Be restrictive in your role assignments. But we also want to simplify our administration by establishing work roles, creating corresponding groups for those work roles, and then we assign those roles, assign those groups to roles within DX. I'll have a graphic that'll explain that a little bit better later. Then we add the users to groups. That's a very convenient way to administer, authorization within the product. There is one virtual group that's very important when we start talking about cloud identity, and that is the all authenticated portal users group. Roles assigned to that group extend to anyone who is logged into the system. So that's a very simplified method of authorization, is simply granting access to everyone who is authenticated. But we're not here today to talk about web security in the abstract, or even web security as a concept within digital experience. We're talking about cloud identity specifically. So what is cloud identity, and what are the reasons that folks might choose to use it? So a cloud identity provider is essentially an online user repository service, right? It is a means of replacing an on-premise repository like an LDAP. And very often we see requirements coming down from the business, right? We are no longer interested in incurring the costs of maintaining our user repository. We are not in that business. We would like to pay a service to do that for us. Therefore, you must integrate your application with that service. And those services you may know better by name. Microsoft Entra ID is the current name of Microsoft's offering. It used to be called Azure. I think it had a name associated with Active Directory at one point. But also there's the Google identity, Okta, you may be familiar with. As you dip your toes into this water, I encourage you to look at Auth0 as a very useful resource, because that is a nice playground where you can do a lot of practice with OIDC outside of your the actual offering like Okta, and then Amazon Web Services Cognito. Now, that is not the only reason that businesses might choose to go toward an identity provider. They may not want to externalize their user population, especially if it's something very sensitive like a government application, right? But they may want to reap the benefits of OIDC that pertain to security. So they may have implemented an on-premise identity provider. And the ones you see there very many times are Keycloak and Authentic. And those are on-premise offerings that offer an OIDC interface. And on-premise may be stretching the term a bit. Privately administered may be a better way to put that, because very often, like we have in our reference materials, Keycloak's going to be running in the cloud somewhere, but you would have control over it in a way that you don't have control over, say, Microsoft Entra ID. But forget about the business. What about application architects? Why might they choose to go towards a cloud identity provider? One big reason is that you have security requirements that your current application either cannot address on its own or would be very costly to address on its own, right? Your chief information security officer may have said, we need to move away from username password and move towards multi-factor authentication, right? Well, imagine doing that for all of the applications that you own. Password policy enforcement comes up all the time when customers are looking at their security scans, right? I was able to test 100 passwords and it never locked me out. Well, traditionally we've said that's not something you do at the application, that's something you do at the repository. Well, if you have a single identity provider, they can do that for you. Limiting failed login attempts, same thing. Being able to integrate across a standard within your whole organization is a very attractive thing. But one of the most interesting things about OIDC to me is that it eliminates attack vectors against user credentials. When you're integrated with OIDC, the user credentials never go to the application whatsoever. And if you couple that with, okay, we're no longer maintaining our own user repository, then you shift that risk away from your organization, and it is in a secure and well-tested implementation that not only avoids risk for the application, but it saves time for the developers of your application as well, that they don't have to solve these problems. They have already been solved at the cloud identity provider level. So the current standard for integrating web applications with cloud identity providers is OIDC. That's short for OpenID Connect. It was developed in the context of OAuth 2.0, if anybody is familiar with that. It is an identity protocol that enables applications which in this context are called clients to verify the identity of a user. So again, the user submits credentials to the OpenID Connect provider. You'll see that sometimes referred to as OP, OpenID Connect provider, OIDC provider, or IDP, identity provider. Those terms are essentially interchangeable. And then the identity provider via secure channels, these are secured via certificates, gives information about the user to the application. Okay, so that is all of the introduction materials here. I don't know, Dan, if this might be a good place to stop for questions, if anybody's raised their hand or if there's anything in the chat. Like I said, I can't see it right now.
Yeah, there's no questions yet.
All right.
Nobody's raised their hand, but yeah, let's continue for now.
All right, let's continue on with the digital experience side of things then. So again, I'm in level 3 support. I'm going to give you my perspective on these things. You're going to see it the way I see it. And we'll really dig in under the hood later. But at a high level, when you say, how does digital experience authenticate users? The short answer is, we don't. We ask WebSphere Application Server for traditional digital experience, or Liberty for digital experience Compose to do that for us. So there are two parts of your site, right? Your public, which out of the box is WPS Portal, and the authenticated portion of your site, which is WPS My Portal. Of course, these can be customized, and this convention extends to other things like Content Handler, My Content Handler, but you get the idea. There's a public site and there's a protected site, or a public URL and a private URL. So when somebody requests an authenticated URL, then WebSphere looks into its security configuration, says, okay, well, what's my repository? And the current implementation of that is Virtual Member Manager. And under Virtual Member Manager, you can create a federated repository, which is any combination of LDAPs, file-based repositories, database repositories, and custom user repositories. So today we're talking about moving away from the LDAP and moving towards what will be implemented as a custom user repository. And then the other aspect of WebSphere security configuration are the trust association interceptors. These configured interceptors get first shot at authenticating any given request. So there are really two main methods defined in the interface, and that allows WebSphere to poll the trust association interceptors and say, can you authenticate this request? If they come back and say yes, then it calls another method to actually do that authentication. And this is also very important for OIDC, as we will see momentarily. Okay, next step, how does digital experience authorize users? If you're not familiar with this, these graphics, they're very powerful. They explain essentially how roles combine and how role assignments propagate across resources controlled by digital experience. So I don't know if you can see my pointer, but you have content nodes here. Those are all your pages, your labels, your URLs that are defined all under here. And then you also control access to other resources such as users and user groups, It's all laid out very nicely for us in the product documentation. Then, of course, you have your least privileged users down here, and that goes up this tree to the most powerful users, who are the administrators. And those are the roles that exist for these various resources within digital experience. You access these through administrative interfaces. Any portal administrators on the call will be familiar with these. And then this graphic was for release domain. Those are all of your pages in your site. And then there is a separate content hierarchy for web content. And that is what we call the JCR domain. And that tree is a little bit different, but the propagation is essentially the same. You have other administrative interfaces for controlling access to libraries. And then once you drill into Web Content Manager, you see other interfaces where you can control access as content items move through a workflow. And you'll see here we have some workflow defined roles that have been assigned to these virtual users I was talking about earlier, or rather the virtual user group. All right. So,
Jason, can I ask a
yes,
question?
absolutely.
This is Dan. It helps me understand some things, right? So we've talked a lot about the WebSphere security model when you've been talking about like virtual member manager and security.xml.
Mm-hmm.
What are the pieces there? So is it all WebSphere application server that is managing the security, and then portal is taking that and moving it forward, or how's the interaction there, I guess is my question.
So WebSphere provides certain administrative interfaces to manage its security. Those are not intuitive and don't always can't be automated very well sometimes, or they take a lot of effort to automate. If you start looking at WS admin scripts, you know, when you want to make Jenkins jobs to build out your servers, right? So almost every aspect of security configuration, digital experience provides its own interfaces for. And those are going to be your config engine scripts. We offer GUI, which is config wizard. And I will go on to say that digital experience leverages the full functionality of Virtual Member Manager in ways that I have not seen in any other WebSphere-based product. So some administrative interfaces are unique to digital experience for historical reasons, right? Managing realms relative to virtual portals is the big example I'm thinking of there. But we do provide nice ways to customize the attributes that are defined, user attributes that are defined within VMM. We offer granular controls over how groups are resolved, things like that. So even though they are WebSphere constructs, digital experience makes it their own and puts it in the context of the DX-based application. And I think
Thank you.
Hopefully this section of the presentation will dig into that a little bit more and enlighten you a little bit more there.
Thanks.
All right. So I wanted to go through two scenarios here. One with a traditional legacy approach to authenticating a user, and the second with an approach for the future. So you can see what's actually happening under the hood when these things happen. Okay. So a request comes into the web container saying, I would like to access this protected URL called my portal. WebSphere says, well, the basis for me knowing who you are is the lightweight third-party authentication token. That is a proprietary single sign-on solution that was developed by IBM years and years ago. But it says you don't have one of the LTPA tokens yet, so I need to authenticate you first. And you can think of this token as a name tag that only the web application can read. Okay, and it's got all sorts of fancy math and certificates surrounding it, but it is a name tag that is invisible to everybody else in the world except for the web application. So it says, well, I don't know who you are. I better ask the application how they would like to log you in. And Portal has, configuration for that in its web XML. So it says, well, I'm going to redirect you and eventually send you to the login page. And the login page, we actually have a servlet listening on this redirect URL. The servlet looks in Portal's configuration. It says, okay, I need to send you to the page with unique name wps.login. And what lives there by default is the login portlet. Now, what you see on this screen is the user actually submitting their credentials, right? This is the off-the-shelf login portlet. There's nothing fancy here. The username and password are passed through in web form data. Why is that important? Because it keeps it out of your web server access logs is the big reason from a security perspective. It needs to be form data. And this is the reason that it is very important that you run all of your traffic over secure channels. In other words, HTTPS. You want to make sure that this is encrypted when it's going over the air and over the wire. Those credentials reach the Portal server. And of course, we do not log any usernames and passwords. But we call the authentication service saying we are logging this user in. As I mentioned earlier, the WebSphere configuration here says, hey, virtual member manager, you are the federated repository. Please log this user in for me. And again, it only logs the username. The password is just a reference to the memory holding that password. And it looks through its configuration and figures out which LDAP it should authenticate against. It first searches for the full distinguished name because that's required for the next step. So it uses the user ID and all of the information in VMM configuration to search for the user. And then it makes an LDAP bind call, which is just a method that is defined in the protocol to use that user distinguished name and password and have the LDAP validate it. And on the back end, what's happening there is that LDAPs hash the password and then match it to the hash that it stores in its database. At least that's the way a secure LDAP does it. So the actual passwords are never stored in the LDAP's database. That's important in the LDAP world. So the authentication then is complete once those credentials are verified and an LDAP token is set on the response. So that's now you have a name tag, and now Portal can look you up as a user, right? Redirects you to the secure section with the set cookie. There's some security things I'll just wave my hands at now because I want to get to the next section. But you have that name tag, and now you can traverse the site, the authenticated site. This is the most important part for Portal after authentication completes. And it plays a very big role in cloud identity providers. Portal needs to be able to locate the user in the user repository. It needs to be able to load attributes of the user. It needs to be able to resolve group membership for the user. It needs to be able to do those things to do all of the authorization functionality we talked about earlier, for any personalization work that's dependent on user attributes. But it is a fundamental concept for digital experience that we be able to locate the user in the repository. So what does that mean if you no longer have an on-premise user repository? It means we need to be able to maintain the identity of the user only in memory, and to never have to leave the application in order to get user information once they're inside digital experience. So for your awareness, I wrote a white paper years ago. I did it in 3 steps, where I did a very simple integration with Auth0. Then I did a more complex integration with Auth0. And then I did a dual configuration with both Auth0 and Google. I chose those at the time because they were easy for customers to work with. We had gotten several customers requesting Google integrations. We do not currently have any sort of white paper on Microsoft Entra ID, and I'd be curious at the end of the presentation to know if there's some interest around that as well. Going beyond that, I work closely with a development team that is shared between multiple HCL products to implement a reference implementation with KeyCloak. And again, that's the OIDC provider that you can host in your own cloud services. And so that reference implementation is out there for you, whichever pieces make sense for you to use in your application. So what happens when you're integrated with OIDC is that we leverage the Trust Association Interceptor interface. And we configure a Trust Association Interceptor that is capable of integrating with the identity provider and to establish the user identities. And when we get to the point of looking up information about the user, then we have implemented a custom user repository that lives within the context of Virtual Member Manager, so that we can look up the information about the user from memory rather than from the physical repository. And the biggest hurdle in getting this implemented is choosing how to write the Jazz login module that actually builds the subject that the transient user code reads from. And you'll see what I mean when I say subject here in a moment. That is the representation of the user in memory. Understand, transient users are not required for OIDC to function. The reason I'm bringing them up here is because in at least 75%, if not 90% of the customers I've worked with, they have been given the task of getting rid of their LDAP and going strictly to cloud identity providers. but most of these providers provide ways to synchronize the user base with a local LDAP. So if you have that option and you want to take incremental steps towards transitioning to OIDC, you could handle all of the authentication side first, leave LDAP the way it is, and simply synchronize the identity provider with your local LDAP. Then you get through that, then you could take the second step further down the road of implementing transient users. And of course, the other there are other reasons you might choose to keep a local LDAP as well. But in the case of, say, Keycloak, right? Keycloak can do the authentication for you, but then you can point to the same LDAP that Keycloak uses, and so not need transient users in that sort of scenario. But I'm focusing on the OIDC plus transient user case because that's where I've seen most of our customers moving toward. And these traces were all taken from a lab system running our reference implementation. So we're at the exact same starting point as we had from scenario one. A request comes in for the protected site. There's no LTPA token. What does WebSphere do? It says, well, I have a trust association set up. And in fact, we're using this specific trust association interceptor called the relying party. And that is a term that is a term for the application in the realm of OIDC. You have the identity provider, or the OP IDP. That's the cloud identity provider. We are the relying party. We are the application. We are the client. Any of those three terms refer to this relying party. So this is a bit of code that's executing in the JVM, and it pulls it with that first method call. Can you handle this request or not? Is target interceptor. And of course, the relying party code says true. In fact, I can authenticate this request. And so then WebSphere makes the second method call. Okay, we're going to negotiate and validate established trust. Okay, and via the configuration for this TAI, it says, okay, well, I know where to send you. I know to send you to the identity provider's login screen, right? So it returns an HTTP 401 and actually uses JavaScript to do that replacement of the location. In other words, to send the browser to that login screen. And from there, you land on the login page. In this case, it is the Keycloak login page. And then you are posting credentials to that login page, right? Interesting part, what I mentioned early on in the presentation is that the user credentials are exchanged with the identity provider, not with the application. And this is a simple case of username and password, but you could have multi-factor authentication involved here as well. Once the identity provider is satisfied that you are who you say you are, it sends you back to the your application via a landing page for the relying party. And then the relying party consumes that information that was given to it from the identity provider, right? There was this, I didn't mention it here, but you'll see it in the traces. There is a cookie that it reads from the headers that it uses its back channels to the identity provider to validate, and then it sends you on to the URL that you requested. Here is my portal, and then the TAI is done with its work. Right, so control then goes to the login modules. Okay, these are defined in WebSphere's security configuration as well. And I'm not going to click on it right now, but this actually goes through to our reference implementation so that you can see exactly how this login module works. This login module populates the user attributes in the system memory, and then it establishes group membership as well. So these bits of traces here are specific to this reference implementation of the login module. But this is the subject that it generates. You'll see it puts it in this Java object called an external identity credential. And that object has attributes that are necessary for digital experience to function properly, right? The email address, the unique ID, which is equivalent to a distinguished name in the LDAP world, a UID, a surname, a common name. And you can see that this is a very simple implementation. We didn't do a lot of work to flesh this out, but we're simply setting that to the user ID that they logged in with here. You can get as fancy as you want to, though. All right, this is just a bit of VMM configuration relative to that transient user. So now we are at the point we have gotten through the trust association interceptor. We have run the Jazz login module. The information about the user is stored in memory. So now we finally get to digital experience taking over control and us trying to load the information about the user, which is, as I explained earlier, is necessary for portal and WCM functionality. So we say, hey, VMM, give us what you know about this user. And this is the workhorse for transient users. It is an in-memory adapter that is, this is HCL code here. And it knows how to read that subject that we looked at earlier and answer the questions to every VMM API call that Portal might make. So you can treat these users that exist nowhere other than in memory in an equivalent way to users that exist in a physical repository. So here we are, we're getting information about the user. It says, yep, it is a person account, just like any other in VMM. And here are its property control is a VMM terminology for attribute values. And we add a little bit of extra information in here. We know that transient users are transient users. And by default, right, if you do nothing in your Jazz login module, these transient users are included in the virtual group called all authenticated users. So if you have a very simple site and you only need to distinguish between authenticated and unauthenticated, then you can use this virtual resource to manage your Lasamas there. And the white paper goes into detail about how you can assert group membership. And if you are interested in implementing transient users, I encourage you to read not only the reference implementation, but to also go into the white paper as well, because the reference implementation essentially only looks at one attribute that is given in the claim for the user. In other words, the JSON web token that the OIDC provider sends you. I took a different approach in the white paper. I actually show you how you can make API calls back to the identity provider to resolve group membership for you, and then assert that group membership in the subject. So there are a lot of options out there. This is very flexible as you are capable of writing code for. Or, of course, HCL Services is always there to help you if you don't have those sorts of skills in-house. So we're nearing the end of the presentation here. I'll just
Jason, I have a question that
Mhm.
I'd like to raise. So I think it came a little bit earlier, but here's the question. Can I have multiple authentication methods enabled at the same time, like SAML, OIDC, and form-based login together?
Yes. So the important thing to know when it comes to, let's talk about SAML and OIDC first. You would have two different trust association interceptors set up. There's a SAML specific one and an OIDC specific one. You cannot specify the order in which the trust association interceptors are pulled. So their configuration must not overlap. There must be something specific in the request, whether that is a cookie, whether that is a header, whether that is a URL filter, for example. But there must be something specific in the request that the TAIs can use to distinguish, is this mine or is it yours? Otherwise, you get into a situation where one TAI thinks it can authenticate it, and then when it fails, it will not move on to any other TAIs, right? So that's the gotcha when you talk about having multiple identity providers or external security managers. The TAI scopes must not overlap. And so then you say, well, can I also host my own login form? And the answer is yes. If it falls through all of those TAIs that are configured, then it will still redirect you to the portal login page. When we set this up in the lab, Alex Lang and I did a presentation years ago where we set this up in a lab, and we actually hosted the login form for the OIDC provider in Portal. So, there is a ton of flexibility here, a ton of complexity here. So if you have questions about implementing something specifically, please reach out to support. Use my name if you want to. If level 2 cannot answer it off the top of their head, they're going to tap me on the shoulder, and we can schedule calls to talk through it and to work through it. All right. Did that answer the question, or do we have other questions, Dan?
No, that's the only question that for now. So
All right.
continue.
All right, great. So there are certainly challenges to moving towards cloud identity providers. The biggest challenge is, in my view, the biggest challenge is defining groups so that we can assign those groups to roles. And then how do we get these transient users in to belong to those groups? Right. OIDC is designed for authentication only. It doesn't touch group resolution as a protocol. What that means in practice is that every identity provider does this differently, and we can't just write one login module to cover every identity provider. So these transient users belong to only one group by default, all authenticated portal users. But you can do whatever you like within your custom Jazz login modules to resolve group membership and then assert that in the subject. The login module can grant transient membership to any arbitrary group that exists in your repository. And that includes doing things like making API calls to an external service to resolve group membership. You have to configure Portal properly to use that group membership, but it can be done. What you cannot do is administratively assign group membership to transient users, right? A transient user by definition exists only in memory, only for the period of time they're logged in. You cannot say, I want this transient user to belong to this persistent group. It simply does not work. But you can do whatever you like within your Jazz login modules to assert that they are members of that persistent group. So that's an important distinction that we had a customer case on very recently, in fact. The other big consideration are user attributes, right? The claims we receive about these users, the JSON web tokens that represent the user from an OIDC perspective are usually pretty sparse. They don't have a ton of user attributes in them, maybe not everything that your application needs. So how do you fill those in? Does the identity provider give you a way to extend what is in the JSON web token that you can just read when he comes in your login module? Are you going to implement logic in your login module to assert some arbitrary attribute values? Just thinking off the top of my head here, this could be something like, just their location, right? Whether they came in from the Americas or from Europe, things like that. And you can, very many of these identity providers provide APIs not only for group membership resolution, but also to get attributes about the users. So you can make the API calls within your login module to fill in those details as well. And then Digital Experience treats those attribute values just like they would attribute values obtained from LDAP. All right. The reference implementation is a great starting point for looking at how a login module should be constructed. I gave you other examples in the white paper, and both of those cover ways to assert group membership. The big thing to know here is if you're going outside of Keycloak, Auth0, and Google, that is going to require custom Java code. There's currently no off-the-shelf Jazz login module that would work for an arbitrary cloud identity provider. So, I really encourage you to speak up if that is to me today, if that is to Dan offline, any lab advocates, any relationships you have, and even through the enhancement request interface that we give you online. Tell us what you want to see in the product so that we can make the product do what you need it to do. Okay. Last slide, and then I want to come back to this one. I spoke earlier about how OIDC does not require transient users, right? You can integrate with cloud identity providers and still maintain your own LDAP. So certain providers give you ways to synchronize to your LDAP, but there are some considerations there. What cycle does that work on? Does that cycle meet the security requirements for your application? In other words, if I remove a user from the cloud identity provider and he still exists in the LDAP until the next synchronization cycle, does that mean he can still access all the data that he could before he was removed, right? Can you kick somebody out of your organization and ensure that they can't still get in? We've had the issues with cleanup users for years. You know, this is whether remnants of old users persist in the portal database. Will you have to clean them up if you change to this sort of synchronization process? Will their external identifiers be persistent forever and always? And finally, this negates, using an LDAP negates a major reason for moving to a cloud identity provider, but perhaps it is still the best thing for you. Okay, but I did want to just, we have a few minutes left here, let you see what I'm talking about with the reference implementation. This is all public. It's linked from our product documentation. But you can see here, this is our custom login module, and we just implemented an interface so that we could plug into WebSphere or Liberty. But it does do things during this login process to set user attributes. It's pretty straightforward there. And then we have a different method call to resolve group membership. And the way we did that here is we were just looking at attribute values that were specified in the information we got back from the OIDC provider. So I know I threw a lot of information at folks today. I don't know what anyone's time constraints are, but I'm happy to stay on for a bit to answer any other questions that we might have. Dan?
Yeah, so there was a question about getting the slide presentation,
Yeah.
and essentially send me an email and I will send it back to you. I don't want to send it out as a blast, so just request it and I'll send it over to you. Another thing is, so chatting back and forth with some people, they were asking about the DX to DX compose, if you could give a short difference between the two. I'm sure there's a lot, but
one uses WebSphere application server and one uses Liberty. And the member manager in Liberty was not as fleshed out as the member manager in WebSphere. So more of the code to interact with user repositories is maintained by HCL in DX Compose. However, that said, transient users work essentially the same way, right? Because all we've done is implement a custom user repository within the member manager. So that code would be shared between Compose and traditional DX.
Okay, support as well. So, support cases. And we thank you all for joining today.
Thanks,
and we'll
everyone.
talk
It's
to you.
been I've enjoyed it, and Dan, thanks again for having me.